Good morning or good afternoon, it's Miss Bauer here, and today we're going to talk about everything that you need to know, that's what NTK stands for, that's going to help you be successful in Unit 5. So, Unit 5 is still all about triangles, and remember that a triangle is just a polygon with 3 sides. So we have a picture of a triangle over here. You're familiar with triangles. And what we get into with Unit 5 is how do you make triangles? Like what if 2 sides are too short? So for example, what if you had a length that long and a length that long? And then you had a third piece, but your third piece was only that long. Well, then you wouldn't be able to make a triangle. So that's what we're going to get into in Unit 5 is how do I make triangles? How do I build triangles? And then how do I find all these missing parts in triangles? So a triangle is a polygon with 3 sides. We have a picture over here. And this specifically is a right triangle. So a right triangle is just a triangle with a right angle. And remember that a right angle is just 90 degrees. So you could write that down too if you want. And we notate that with a box, with this little square box thing. That's how I know that this is a right triangle. If we don't see the box, then we can't just assume. We need to see that box to know if it's a right triangle. So triangles are named with 3 letters. So I would call this triangle ABC. And I could say triangle BAC, BCA. We'll tend to stick with alpha order though. So this is triangle ABC. Now, in solving right triangles, you probably are familiar with Pythagorean Theorem. Now, maybe you remember it, maybe not. Pythagorean Theorem was a squared plus b squared equals c squared. And these were parts of your triangle. So maybe you remember this, maybe not. Like I said, some of you remember this, some of you it's been a while. C always had to be the hypotenuse of your triangle. And the hypotenuse is your longest side in a right triangle. It's the one across from 90 degrees. So 90 is our biggest angle, which means that the side opposite it should be the biggest side. So that's our hypotenuse. And a lot of people have trouble spelling that word. You can also just write HYP or hype for short. Your hypotenuse had to be C. And then A and B over here, notice we're using lowercase letters. A and B, we're always talking about the legs. So the way that I remember it is in a right triangle, your leg should make an L, just like that. And it might be a crooked L, like it might go that way. Or it might be a backwards L, like that. But your hypotenuse is the one across from the box that connects the L-shaped legs. So Pythagorean theorem is pretty much just that a leg squared plus a leg squared should equal your hypotenuse squared. And we'll dive into details with all of this stuff later on a little bit more as we move throughout this unit. But for now, I just want to bring some things to the front of your mind that you might have forgotten about. Something else we're going to get into this unit is Pythagorean triples. Pythagorean triples are whole numbers that fit a squared plus b squared equals c squared. There's a much longer definition. It's the set of whole numbers that would work to make a squared plus b squared equals c squared true. Let's just say whole numbers that fit a squared plus b squared equals c squared, or Pythagorean theorem for short. Now, not all whole numbers would fit Pythagorean theorem. If I used 1 squared plus 2 squared, well, 1 squared would be 1, 2 squared would be 4, so then c squared would be 5, which means if I'm trying to find c and I square root it, I'm going to end up with a decimal. And that's what we get, is a lot of decimals without Pythagorean theorem. But we have some Pythagorean triples, or some numbers that just work, and they work really nice and neat. And one of those, the main one, is 3, 4, 5. So if I plug in 3, so I get 3 squared plus 4 squared, it should equal 5 squared, and it does. 3 squared is 9, 4 squared is 16, and 5 squared is 25. 9 plus 16 equals 25. And now you have to remember that squared means times itself, and so it works out really, really well. Another combination of those numbers is 5, 12, 13. Not all numbers work for Pythagorean theorem, and not all numbers are Pythagorean triples. But Pythagorean triples are like these little shortcuts. They're really nice and neat. So 5 squared plus 12 squared should equal 13 squared. So 5 times 5 is 25. 12 squared is 144. If I add those together, I get 169, which is 13 squared. So Pythagorean triples are like this little shortcuts when everything works out really, really nice and neat. And like I said, we'll dive more into all details with these things later on throughout the next few weeks. But for now, I just want you to be aware that there's Pythagorean Theorem and Pythagorean Triples, and they're related but not the same. Another type of triangle that we're going to look at in this unit is our special right triangles. Special right triangles are triangles that follow this pattern every single time. And there's two special right triangles that we're going to get into. So I'm going to take a second. I'm going to draw some right triangles. Okay, the first special right triangle is an isosceles right triangle. Now, if it's isosceles and triangles add up to 180, so if I do 180 minus 90, I get 90. And then when I divide that by 2, I get 45. So an isosceles right triangle is also known as a 45, 45, 90 triangle. That's the first special right triangle, 45, 45, 90. And 45, 45, 90s follow this rule every single time, and the rule is 1, 1, root 2. Now, that's not going to mean much to you right now, but we're going to talk more about that later. Like I said, today is just all about what are the terms that you need to know, what are some patterns that you're going to see later on, kind of like an introduction for Unit 5. Okay, our other special right triangle is if it's 90 degrees, and then it's split into thirds, so it's 30, 60, 90. That's our other special right triangle. So 45, 45, 90, and 30, 60, 90. These are two special right triangles because these particular triangles happen to follow a pattern. And the pattern for 30, 60, 90 is 1, root 3, 2. Now, we'll talk more about those patterns later on as we go throughout this unit, but a lot of this unit is looking for patterns in triangles and then solving with those patterns. Okay, a big part of this unit is trig. Now, trig is short for trigonometry. Which always seems like a scary word to people, but I can assure you that trig is one of the easier things that we're going to do in geometry. So, trigonometry is trig for short. And if you look on your calculator, you probably have seen like this, it says instead of sine, it says like sin. Instead of cosine, you see cos. Instead of tangent, you see tan. Take a minute and see if you can find those numbers, those buttons on your calculator. And that's because trig is pretty much make the calculator do the work for you type of problem. Trig is pretty much we're going to use the calculator, find our answer, and it just boils down to can you figure out which part of the triangle is what. So this word right here is pronounced sine, but we abbreviate it because with trigonometry, we even abbreviate trigonometry to trig. We abbreviate everything in this unit. So instead of sine, you're going to see it like this, S-I-N, but we still pronounce it sine, not sin. And your formula for sine is sine of theta equals the opposite side over the hypotenuse. Now, theta just means an angle. We're talking about triangles, so we're going to have some angles in there. And so sine of theta would be sine of my angle equals opposite over hypotenuse, and then the calculator is going to do the work for you. So here's kind of what that would look like. I'm just going to sketch out a triangle down here. It's going to be a right triangle. And let's say that I make this angle over here theta. My right angle will never be theta. So theta just means angle. So sine of theta, I normally would have a bunch of numbers. So sine of theta would be opposite over hypotenuse. Well, your hypotenuse is your side that's across from your right angle. So that would be my hypotenuse side. My opposite side would be the one that's across from theta. So that would be the opposite side. And then I pretty much just plug my numbers into that formula and the calculator is going to do the work for me. Part of why I'm showing you this early is because students tend to see this and they freak out. And I can assure you that it's nothing to freak out over. Whenever we get there and whenever we start talking about trig, you're going to realize how easy it is. Now, cosine, we abbreviate to COS. So cosine of theta isn't opposite over hypotenuse. Cosine of theta would be adjacent over hypotenuse. So if I go back to this triangle, well, opposite theta is opposite. Opposite the box is hypotenuse, and then that last side would be the adjacent side. Which brings us to our last trig formula, which is if I only have the legs. So my last trig formula is tangent, which I'm just going to call it tan for short. So tan of theta is opposite over adjacent. Now, when we talk about trig, we'll talk about this thing called trig inverse as well. Trig inverse is the buttons on the calculator that look like this. It's like sine with the -1, or cosine with the -1, or tangent with the -1. Those formulas help you find a missing angle. So I use trig inverse if I'm missing an angle. So just be aware when we get into trig that those two buttons on the calculator are going to be a little bit different. Now, with right triangles and Pythagorean Theorem, and even with our special right triangles, this symbol is going to pop up a lot. Now, you're used to calling that a square root. That can also be called a radical. Radicals are a big part from Algebra 1. Maybe you got to it, maybe not, and they're also a big part in Algebra 2. But a radical is just like a square root. It's something that we're going to see quite often in this unit. And we'll talk more about radical form in just a bit. So hopefully you remember that the legs are the sides that make the L, or essentially the sides that make the right angle. And hopefully you remember that the hypotenuse is the longest side. It's across from the right angle. Also known as the longest side in a right triangle. My adjacent side is the leg that's pretty much like touching theta, if you want to think of it that way. So your adjacent side is the leg touching theta, or forming theta. And our opposite side is the leg across from theta. So there's two skills in this unit that are just going to help you crush it and do very, very well. And that's, can you figure out which part of a triangle is which? Can you figure out what's the leg, what's the hypotenuse, what's the adjacent side, what's the opposite side? Because if yes, you can use your formulas and make your calculator do the work. The other key part of this unit is, can you simplify radicals, which is a skill that we're going to talk about in just a bit. So I'm going to give you a moment to just refresh, take a breather, and then hop back in with the next video as we discuss how to simplify radicals.